My name is Justin Noonan, Technical Marketing Engineer. With me is Freeman Wong, who is one of our developers who helped develop the EST or Enrollment over Secure Transport feature. Also on the horn to answer questions is Arafi Lee from the Network Test Lab, who's been testing EST. So let's get started. Uh, Enrollment over Secure Transport. Let me share my slide here so you don't see my thing. So enrollment over secure transport is a protocol to help um, simplify and automate a lot of our public key infrastructure key exchanges. So with a enterprise network, enterprise in general, we have to be able to secure devices and be able to have a trusted infrastructure so that data can be exchanged in a trusted and secure environment. So we use what's called a public key infrastructure, or PKI, for that. It's a technology for authenticating users and devices. The idea, the notion behind this is that each user or device has a specific key, a unique key associated with that. And we encrypt this key using cryptography and encryption, and we can sign that key to exchange the key between the devices. We sign that key as part of a certificate. So a certificate exchange, if any of you are familiar with configuring downloadable user roles, you'll understand and remember that you have to load a certificate on the switch to be able to create a trust between ClearPass and the switch to download the role, as well as other applications that we have like RADSEC or um, HTTPS, um, captive portal. There's different applications that the switch can use that we need to have a trusted infrastructure between. So the cryptographic key is shared between these devices and users using a certificate that's signed by a trusted party, which is called the certificate authority. So the certificate authority is this trusted entity that can help prove the identity of a device or user throughout the public key infrastructure. So EST stands for Enrollment over Secure Transport, and it defines the protocol that devices are used to request the Trusted Certificate Authority certificates. So sometimes you get a certificate chain with these devices where you have the Certificate Authority certificate and then any intermediate Certificate Authority certificates as well that all come in this chain to the switch. Now, when we're manually doing it, traditionally we would have to manually generate a signing request and then go and have that certificate signed by the certificate authority and then copy that certificate back into the switch. All manual uploading. Um, Part of the reason that we do that is to make sure that we have the trust between the devices. So EST allows us to simplify that and automate a lot of that because the EST is going to act as the go-between between the certificate authority and those devices. And then we can automatically enroll and re-enroll certificates over a trusted connection using, as we use in CX, HTTP over TLS. So this is based on RFC 7030, which was ratified in 2013. So in the AOS-CX operating system, the switch can now act as an EST client in AOS-CX 10.06. So now we've gone from a manual state where like when we introduced RADSEC with 10.5 and we had to manually upload certificates for that, now we can use an EST server for RADSEC certificates or radius security certificates to be able to automatically enroll and re-enroll RADSEC clients. So things we need to consider when we're using EST on CX, we gotta make sure we got connectivity in the TCP network between the switch and the EST server. We use DNS, and then we have to be able to reach the EST server from the CX switch. So some of the use cases with that, previous to EST, we use what was called the Simple Certificate Enrollment Protocol, or SEP. So EST is a lot easier to implement than SEP. That's why they came out with the IETF came out with a new standard, and then it also supports more security algorithms. So it leverages HTTPS as the transport and TLS for a lot of the security with it. So the main use case is that we can now enroll and re-enroll certificates automatically instead of a manual enrollment. So let's take for an example, we have a RADSEC client and it needs to, the certificate expires, so it needs to re-enroll the certificate. rather than, as I mentioned earlier, having to manually do that. The EST server can do it automatically, and as Freeman will show, we can set a time period to start that process in CX. So some of the common supported services and service certificates that we support in CX are syslog, HTTPS, captive portal, RADSec, and then kind of a newer one is a hardware switch controller. Some technologies around in the industry use a controller base, not like a mobility controller, but like a VXLAN controller or things like that. Any kind of hardware controller that requires a certificate, we can be able to support that with an EST server. So with that being said, I will turn it over to Freeman to go into the details of the feature.
All right, thank you, Justin. Let me share my screen. Can you see my screen? Is the slide?
Yes, we can see it.
Okay, good. So like Justin said, that the EST protocol is a client-server architecture. So the EST client will request a certificate from the server. What we added new to the 10.6 on our CX switch is a EST client implementation. So we, on the switch, you would configure a EST profile that tells where is the server, right? Where's the server the switch will connect to, right? You create EST profile, and the EST profile will include parameters like the server URL, the VRF where you can get connected to the server, and at the time you configure the EST profile with the server URL, the switch will try to contact the EST server well before you enroll certificate, right? Try to ask the EST server to get, hey, please give me a set of trusted CA certificates. And the switch will install the trusted CA certificate on the switch as TA profiles. We call it trust anchor profiles. Probably many of you have been familiar with that. It's an existing feature on our PKI infrastructure. And so we also expand our existing certificate user interface to enroll certificate over from EST server. So right now, our user interface can enroll certificate, but it's in a manual fashion, right? You either copy paste a certificate onto your CLI console or copy paste a certificate onto your web UI interface, or you ask the switch to generate CSR and you take the CSR manually to the CA server, get signed, and then copy paste it back to the server, back to the switch, right? So we expand that user interface. Now, when you say enroll a certificate, you can give a EST profile name as the parameter, and the switch will contact the EST server and ask for a certificate enrollment. And here are some numbers that we are supporting right now with our current implementation on 10.6. There's nothing very super interesting. It's just some numbers. Like we support 16 EST profiles. That means you can configure 16 EST servers at the same time. And we support 63 trusted CA certificates downloaded from all kinds of EST servers. And you can enroll up to 18 device certificates from EST server. And we support the EST profile configuration both from CLI console and REST API. And the CA certificate enrollment is also supported both from CLI console and the REST API. And let me go to next slide. talk about how we can configure the EST client on the switch. So before you configure the EST client on the switch and get it work, we have some prerequisites that you would need to set up first, right? First of all, you need to have a PKI, of course, for your enterprise environment. So that means you need to have a searching, a CA searching, right? You need to have a root cert, and most likely you want some intermediate certificate, intermediate CA certificate to issue leaf certificate or device certificate, right? It's usually not a good practice to have a root cert directly sign the device certificate. You need to have that kind of searching, and you need to prepare a certificate for the EST server, right? And optionally, you can also prepare a certificate for the EST client on the switch. But for that part, if you want to install the client certificate for the EST client, you have to do it manually. If you want to install that beforehand. Of course, that's optional. We have another way to have the EST client set up without a certificate, which you can use username and password. Right? You give the EST client a username and password, and it can authenticate itself to the server. We'll talk about that later. And yeah, so this step is the only step that you would have to do it manually. You need to install the root certificate that can validate the server certificate, because we need to create a trust relationship with the EST server, right? And this is the existing CLI, a manual installation of the TA profile. I can show you how to do that on a real switch. So I have two terminal windows from my Linux virtual machine. On the top one, I'm going to, actually I have my switch set up. So this is a the serial console to my switch. This is a serial console. I can do all the configuration here, but I would not like to use this. I would like to save this serial console for debugging. I will use that. I will show you how to debug on this window later on. But right now, oops. I would like to telnet into the switch from another Linux terminal to do all the configuration. Right. So from now on, I'm going to use this CLI, this telnet window, sorry, this SSH window to do all the configuration. And in order to install the the root certificate to authenticate the EST server, we have to install a TA profile. Let's give it a name, call it test TA. And I'll copy paste the root certificate. There you go. So it's already installed, right? If you use so run, you can see it as part of the running config here. So this is the only necessary step to set up the EST client to work before you configure the EST profile. And as I said, optionally, you can pre-configure a a client certificate for the EST client, but this is not necessary. And optionally, you can also set for the switch to verify the key usage field of all the certificates. But again, this is optional. And this is required by NTCPP, but many servers out there do not require this. I would suggest you check with the all the client cert, see because once you enforce these, many client certificates will fail because in the industry it's not very common that people set a key usage field with the certificate. And of course, before you can get your EST client to work, you need to have a EST server reachable somewhere on the network, right? And you need to have a server certificate installed. And after you have all those prerequisite steps done, then you can start setting up the EST profile on the switch. I'm going to show you how to do that on the real switch. So it's crypto PKI EST profile. Let's give it a profile name. Let's say test EST, and then you can configure all these parameters, right? All the parameters have the default value except the URL. So at the URL if you do not configure it, it's empty, and of course you would not be able to reach a EST server without a URL. All the other parameters, they have default value. For example, VRF, the default value is management, VRF, and the retry interval, retry count. These are all self-explained by their name. Retry interval is 30 seconds. Retry count is 3, I think. And there's something interesting here called arbitrary label and the re-enrollment lead time. So these parameters are interesting, but they are optional. The arbitrary label is a label that will be concatenated to the EST URL if you configure so. So you can leave it empty. That means the URL you configure for the EST profile will be used to connect to the EST server for all the operations. And in the real use cases, some customers want to have one EST server serving multiple CA servers. And in that case, they would use the arbitrary label to distinguish which CA server you want to request certificate enrollment. So in such use case, you would set up multiple EST profiles pointing to the same EST server, but give them different arbitrary label, right? So in that case, you can the EST server can serve multiple CA servers. There's another interesting parameter called re-enrollment lead time, and by default it's 2 days. That means 2 days before the certificate expires, the switch will launch a automatic re-enrollment request to the same EST server as the certificate enrolled before, right? So on the CLI console, you can see all these parameters available. And of course, to get the EST client to work, the only thing you need to configure is the URL. So before I configure the URL, I want to set up the EST server first. So the window, the terminal window at the bottom is another terminal window from my Linux virtual machine. So I'm going to run my CA server and EST server here. So this is the CA server. I run it in the background. And then I'm going to run my EST server. No, it's not here. I'm going to run my EST server. So in my, for the EST server I'm using, it is an open source EST server. I just use it as a toy. I have to run the CA server first and then run the EST server that will send requests to the CA server. So in the commercial servers, it's usually that the CA server and the EST server are integrated together. For example, in our ClearPath server, I think the two are integrated together, so their communication is like kind of internal. But in my case, if they are separate, right? So I run the EST server on the front at the front ground, so you will see some log messages popping up. All right, now I can configure the URL to my EST profile. HTTPS. And this is the IP address to my virtual machine. And this is the port that my EST server is listening on. And this is the URL I set up for the EST server to process a request. If you read the IFC, you can see that this is just the default URL for the open source EST server. It's nothing special. It's just some preference from the author of the IFC. So once I configure this URL, you will see that a request will be sent to the EST server, ask for a CA certificate. Now you see something happening over here, right? And a set of CA certificate already sent over. You can see that a bunch of TA profile has been created, and they have the name of the EST profile with a postfix that says EST-TA 01, 02, 03, a 2-digit after the TA. So we use this dedicated name to indicate, oh, this TA profile containing a CA certificate from a EST server. It's automatically downloaded from the EST server, right? And once we create this EST profile, we can ask the switch to, hey, use this EST profile to contact the EST server and enroll a switch, right? Certificate enrollment. So to enroll a certificate, we are using the same user interface as the other ways of enrolling certificate, right? We create the certificate context, or we can call it create a certificate name, certificate, give it a name, cert 01, right? And as usual, you configure this subject. No, we can use, we can give it a common name, cert 01. And of course, optionally, you can set a key type and the key size. But by default, the key type is RSA and key size is 2048. So usually for demo purpose, I don't change them. And to enroll a certificate, before we add the EST feature, we have two ways to enroll certificate, right? You either enroll a self-signed certificate that's totally generated on the switch, or you can enroll certificate through the terminal. That means the switch will generate a CSR and display on the terminal. You copy paste it over to the CA server by hand, and you get the CA server signed the certificate, and you copy paste it back to the CLI console. Use the import command to install the signed certificate. So now we add the EST profile parameter, the new option, and we can say EST profile, and we get the EST profile name we created before. I think it's test EST, right? And the switch will say, hey, do you want to enroll this certificate from that EST server? If you say yes, it will contact the EST server. You see there's some action over here, right? So did we actually get it enrolled? We can use the show command to see if it's successful, right? We can show the certificate. Okay, cert 01 is here. Oops, the certificate status is pending, and the EST status is enroll retrying. When it says retrying, that means it fails. It fails, the enrollment fails, and it's retrying because we have the default retry count, right, which is 3, right? So what's wrong? Why we cannot enroll? So remember, we need to establish a trust relationship between the EST client and the EST server, right? So you see the server side is having some action. So that's the switch retrying. Every 30 seconds, it's retrying. So we need to create a trust relationship between the EST server and EST client. So the EST server use the server certificate, send over the server certificate to the switch, and the switch will validate that. And of course, then the switch will trust that. But for the EST client, what it will send over to the server for authentication. So there are two possible ways. The first way, as I said before, you can install a certificate for the EST client globally, and the EST client will send a certificate to whatever EST server you configure. And of course, the EST server needs to have a root cert of your EST client certificate so that the root cert can validate the EST client certificate. So that's one way to do authentication. Another way is your EST server can set up a username password for the EST client to authenticate. And in that case, you have to configure the username password in the EST profile for a specific EST server. PKI-EST, I think it's test EST, right? So you get back into this EST profile context and you configure the username. So the username password I set up with my EST server is Fred, and it's plain text and Bunny. Actually, this is the default username password for the EST server implementation I choose. Right. So now let's try. So you can see after three times of retry, the certificate already failed all the retries and it indicate enroll failed. So it's not going to try again because it failed. So in this case, you may want to delete it, or you can just ignore it. So we are going to create another, let's say 02, subject, right? Let's call it cert 02. Okay. Enroll EST profile. test. Now, given we add the username password for authentication, see if we can make it this time. So again, we see some action on the server side. Here you go. Here's the certificate 02. So it says status is installed, and the EST status is enroll success. So that means we successfully enroll a certificate from the EST server, right? And if you want to control, so when this certificate is approaching its expiry, like by default 2 days before its expiration, the switch will launch a re-enrollment. And of course, you can no, what I want to do. I want to go into the EST profile context, EST profile test, EST. Yeah. So if you want to control the re-enroll time, you would configure the re-enrollment lead time, right? By default, it's 2. And you can configure, I think the biggest you can configure is 30, right? It's 0 to 30. So you can configure it to 30 days maximum. So you can control when the re-enrollment will happen, right? So the re-enrollment is automatic. Given the re-enrollment lead time, it's automatic. It will happen like a number of days before the expiration. But at the time of re-enrollment, the EST client will use the certificate you are going to renew for authentication. So this time it's not username password. It would not use the username password. It would not use the certificate for the EST client, the global EST client. It will use the certificate you are renewing and send that certificate to the EST server for authentication. So this is something special, but it's internal. It's probably, it goes unnoticed if you don't look deep into the login. But of course, in some cases that, like for example, if the certificate you are trying to re-enroll is already expired, right? In that case, the authentication will fail, and the EST client will automatically fall back to the username password configuration if you configured before, or it falls back to the EST client certificate, the global certificate for EST client, if you configured before. But in that case, when it falls back to those authentication approach, the EST client will take it as a new enrollment instead of a re-enrollment. Okay. So this is about re-enrollment lead time. We already talked about. And some show command to check the status. Actually, I've been using those during the demo on the switch, right? I've been using all the show command. You can show certificate, you can show TA profile, and you can show EST profile and so on. And so application, I think many of you should have known about the show application. So this is the, oops. No. The show application is showing what certificate you set up for the applications, right? So right now there's nothing here because I did not configure. Optionally, you can configure a certificate for the EST client, and it will be used for any kind of EST servers. It will send to all the EST servers for authentication, unless you specify username password, right? And this is This slide is showing the Wireshark capture of some of the transactions between the EST client and server. I'm not going into the detail, but if you go deep into that, you will see that the EST client and will establish a TLS HTTPS connection, and after the handshake, it will request for a set of trusted CA certificates to send over, and if that's successful, the EST client will request to enroll or re-enroll a certificate. So let's go next slide. So some best practices. Excuse me. So one thing is that you need to ensure that the switch and the server is sync in time. If the time have a big difference, you may end up with some weird behavior. Like when you receive the certificate, the time is probably the certificate may have given a future time that's not yet valid, and the certificate will be rejected because the time hasn't started yet. Right. And the EST server will have a set of CA certificates, usually stored as a file. Some server may store in other form, and a set of CA certificates that's ready to be sent over to the client upon request. And that set of CA certificates should include intermediate certificates if you have designed so. Right? If your CA searching includes intermediate CA certificate, you should include those in your CA certificate set as trusted certificate. And when you generate those CA certificates, make sure you have the basic constraint field set with CAs equal to true. Right? For example, you need to have this in your OpenSSL config when you generate your CA certificate, right? And this is the how the certificate look like. If you display your CA certificate, you should be able to see the X509 version 3 extension showing the basic constraint has the CA being true, and optionally you can also set the path length. Path length is basically path length means that how many intermediate CA you can have under this CA certificate, right? And you also need to have the key usage field set with the certificate sign. Right. So if you have this line in your OpenSSL config, when you generate your CA certificate, you will get this key usage set like that. Right. And for the client certificate, it's in the other way, right? So you need to have the CA set to false because it's a device certificate, or we call it a leaf certificate. It should not be a CA. And it needs to have some key usage that match the certificate use, like either for digital signature or for key encipherment. And optionally, if the peer server or peer client that's going to validate your certificate have the key usage checking, is enforcing the key usage checking, you would want to set your certificate with this extended key usage, right? To be either server authentication or client authentication. Right? As I said, many servers do not check this, but some servers, if they want to be compliant with NDCPP requirement, they would check this, they would enforce this. So in that case, if your certificate does not have this, it will be rejected, right? So if after you set this, when you show your certificate, you will see this extended key usage field display like that. Like it shows as web server authentication usage and or web client authentication usage, right? And if you look at it from a Windows system, you probably will see something like this. It's a little bit small, but you can see that this basic constraint and subject type is CA. And here's how you
It
check.
doesn't have all the fields in there. It was just an example to show what the field would look like in Windows.
Right. So there's key usage field here. That's what you can use to check. And there's a basic constraint. I don't see the extended key usage. Probably it's hidden at the top. Now troubleshooting. So the most powerful troubleshooting tool we built into this EST client on the switch is debug logging. So I keep this serial console of the switch away from you. I put it in my second monitor just because I want to save it for now. So EST protocol is kind of complicated and a lot of transactions going on back and forth for a simple certificate enrollment. So we're building a lot of debug logging messages for you. To see all the debug log messages, you would want to turn on PKI, right? Debug PKI, or you will see all the debug messages. And you want to set the severity to the lowest level, which is debug, right? I think it's probably this is by default, right? But you want to check and make sure it's at debug level so you can see as many debug messages as possible. And you also want to set you can also set the destination to the console. So console means it will come to the serial console. So it will only come to this terminal. It would not come here because this is the SSH session, right? You can see I SSH into the switch. This is SSH session, and this is a serial console terminal. So the debug log, if you set destination to be console, it only comes to this serial console, right? So now let me try enroll a certificate, see how many debug messages you can get. PKI cert 03. We try to enroll another certificate. No, now this time I want to use the switch serial number as the command name, right? Let's skip everything else. Enroll EST profile, test EST. You see how many debug login messages you can get. So it's for a certificate enrollment. So if I don't have time to go through all this, but if you look deep into it, you try it yourself, look deep into it, you will see that one simple CLI already generate actually at least three big transactions between the EST client and the EST server. And if there's failure, most of failures, you can see it in these debug log messages, right? For example, if the sometimes the EST server, the pin name of the EST server cannot be resolved, you have to check your DNS service. If the connection get rejected, you want to check the EST profile, see if the URL has the correct TCP port set up. So remember that EST Remember that when I configure the EST URL, I do have the TCP port as part of the URL. So this is a must. And yeah, some other error cases. I probably don't have time to go through all of them. And at the end, this is the IFC for the PKI, for the private public key pair infrastructure. And this is the IFC for the EST protocol, just for your reference. And also, as I mentioned before, the EST client configuration can be done both from CLI console and from a REST API. And Justin is going to show you how you can configure the EST profile from the web, from a web interface over the REST protocol.
Sure. And show you real quick. So if you look at the web UI, if you come down here to security and then PKI, we have all the PKI infrastructure now in the GUI. So if I wanted to create a new EST profile, I could do that and then put, test EST server, and I can go ahead and put in all my information that Freeman just showed in the command line, and then I can add that in. You can also do the same with your TA profiles and your certificates, and then you can associate the certificates to the application. So it makes it super, super easy, super handy to do it with the web UI rather than having to manually type it. So that being said, thanks everyone. I think we got all the questions answered, so we can turn it directly over to Steve.